Get started now. Good? Okay, can everybody hear me? Excellent. Well, thanks everyone for coming. My name is Spencer McIntyre, and we're going to talk about Python static analysis. So, really excited to be here. This is like the fourth or fifth time I've talked at DerbyCon, so really excited to be back again. It's always a great time. We're going to talk a little bit about me. Then we'll go over that demonstration preparation, like I had mentioned. So that way we're gonna see the analysis ahead of time. So that way, hopefully, we'll find something at the end of it. But if we don't, rest assured, I have a couple that I'm going to point out. We're going to talk about static analysis overview of Python, kind of sort of like how it works, and then what we're going to do is we're going to talk about really focus in on some of the changes that I made to one of the existing tools that we're going to talk about. And finally, we're going to go over, hopefully, some projects. My name is Spencer McIntyre. I work at Secure State. I do research and development there. I like to do Windows internal stuff. I do a lot with open source projects. One of the ones I'm most proud of is I do a lot with the Metasploit project. And I am a huge Python enthusiast, which is kind of why I started down this path. Because looking for vulnerabilities in Python projects, kind of right up my alley. So with that, does anyone actually have an idea of a Python project you might want to see analyzed? Responder? Already got that one. So I've got what was that?
Zarp, BetterCat. Actually, BetterCat might be Ruby. It's pretty good. Yeah.
Is that? Okay. Anybody? Yeah, just shout them out. Scapia. I don't think I actually have that one. That, fantastic. Okay, so is that under like the Scapia repository? Scapia. All right. Here we go. Okay, so we're gonna go to dev. So one of the things that I actually made, so at the end of this, when we like actually get to start talking about the code, everything that I'm showing is already public as of last night. I pushed it up, so it's all there. The documentation is a bit lacking, but there's two primary components. There's the actual scan engine, and then there's the facilitator. Those are both public, but what I'm actually showing right now is the facilitator that works over Pushbullet. So I'm actually just going to share this link with this Bandit service that I have running on another system. So this is a worker server I have running up on DigitalOcean, and I'm going to send this to it, and it's going to get queued up. And when it comes back, we can see actually scrolling back through here, like I mentioned, I'd seeded it with a whole bunch of projects. Have all of these results right here. So any other ones? I know we got responder. Remember these for the end, and then like I'll go back through and show the results. Yes, in the back. Creepy. If I do a Google search of creepy, I don't really think that's enough. Oh, I forgot that. Darn you, Google. Right, yeah. Not yet. Geo creepy. Excellent. Here we go. All right. So we'll share this one. Any other ones? Otherwise, we'll start moving on. Set. Already got that one. Eyewitness. Okay. And we'll cap it at that one. Eyewitness. Good ideas. Thanks, guys. We'll probably get interrupted by alerts popping up as the results start to come back, but it'll have results, so hopefully we actually find things. All right, so now that we've got that out of the way. Oh, whoops. I actually had that set up for when everyone was supposed to be shouting them out. All right, so static analysis overview. Okay, so why static analysis? Well, we don't need to run the code. We just want to like analyze it in a static state. So what we're doing is like I'm really trying to look for like low hanging fruit. I'm trying to go for breadth here as opposed to depth. I'm looking for any type of project that I might be able to find like a vulnerability in. If you're on an assessment and you know it is like a large Python shop and they maybe have a few projects, like this would be a good way to do. You can like queue these up in the background while you're working on something else. See the results as they're coming back. Maybe you'll find something in one of the tools that you're looking for. On a slightly unrelated note, a couple of people in the audience have been like really preaching to me, and if you haven't been looking at GitHub for information when you're on assessments, you might be missing out on things like static keys, hard-coded passwords, certificates, configuration, stuff like that. It's all pretty common like things that you might find on GitHub, but hopefully with this you might actually be able to find a couple of other classifications of vulnerabilities. So yeah, it's definitely easier to automate, as I just showed. Like I just push that right up into Bandit, and that is going to just run in the background and scan, and it'll print me out a nice little file, and we'll be able to take a look at it from there. no user interaction. We don't actually have to like run the program, don't have to install any dependencies, not messing with like virtual env, anything like that. So it's very, very quick and easy. But like I said, we're definitely going for breadth here as opposed to depth. All right, so how are we actually doing this? Now, the core foundation of this is going to be the abstract syntax tree module that is included in Python. The fact that it's actually included in Python is absolutely amazing because it's really well supported. It works. Python actually utilizes this internally. So when you go to run a Python script, this is how Python parses that and turns it into something that's actually understandable by the interpreter, so it can actually do what you're telling it to do. But this is how we're going to leverage this in order to parse out all of the files, and then we're going to run analysis on the results from this AST module. The one thing is beware of version compatibility issues. So like I mentioned those primary two components. We'll talk about the names right now just so that we can differentiate them. Bandit is a public scanner already, and so I have a bunch of secret sauce improvements to Bandit, which is what I'm going to be talking about. The other component is Jesse James, because at the time I was like, well, like what controls the bandits? Jesse James sounded like a good idea. So you have Jesse James that's actually is that part that's listening in on Pushbowl and allows us to actually like queue up the scans and everything like that. And then you have Bandit. Now Bandit needs to run in the version of Python that you want to run the analysis for, whereas Jesse James starts that in a separate process, and that's you could actually run Bandit with multiple versions of Python, just queue them all up if you wanted to. So if you know that this project is being run on 3.6, you probably want to run the analysis with 3.6. A lot of people are still using 2.7, so while Jesse James is all in Python 3, right now the analysis that we're actually doing is strictly in 2.7. But just something to know about. Some of the syntax issues, it starts to get a little bit wonky when you get into doing the modules and you need to understand like the differences within the different languages. So definitely just something to keep in mind. So the AST module, or the abstract syntax tree module, does all the heavy lifting for us. We don't do any of the parsing ourselves. It's all done by the built-in Python module, which is fantastic, because if the AST module can't parse it, then the code is so broken it's probably not going to run. So if the code is actually usable, then this will be able to parse it. If you have issues like your indentation is off, you have a missing colon or something like that, this won't be able to parse it. But at the same time, you wouldn't be able to run that code yourself. Of course, it's not going to find any kind of like runtime error, missing dependencies, permissions issues, things along those lines. It's not going to be able to do that, but anything that's like syntactically correct, it will be able to parse. So real quick example, you just import the AST module and you just call parse on whatever string it is. This is a very, very simple example, but this will actually return a module object. So it's going to interpret that string as a module, and that string is of course the Python code. This is all the normalization of like the white space for us, stuff like that. It's like you don't really have to worry about any of that. So it's kind of an example of how it gets broken down, because this is such a core fundamental of how we're actually going to like run the analysis. So I kind of want to break it down here. So in that previous statement that we have with like our var 1 plus 2 equals that over there, like I mentioned, that top level call would return a module object, but from that you can access all of the different statements, the different expressions and things like that. And then so each one of these rectangles are actually nodes, and then they're all like color coded for the different ones. So that top level one, that's that module, actually has a body attribute, and that's just a list of like basically every line of code that you have in there, and then each one of those is going to be a node depending on the type. So in this case, our module has exactly one line with an assign statement where we are assigning var to b3, basically in this case right here. So the node types are always going to be the same. So if you always have like 1 plus 2, you're always going to have like a binop node. But depending on the node type, the children nodes will be in different types of attributes. Like I mentioned, that module one has them in like the body attribute. Exception handlers get a little bit odd because you have like a list of like the actual exception handlers and like the else block, things along those lines. All of these things that make a scripting language like Python very dynamic, very like easy to use and flexible and powerful, also make it kind of a bit more difficult to do like the static analysis on it, because there's so many different ways that you can do all of these things. The last color codes that kind of like ran out of space on there, and I don't want it to be really tiny, but you have like the dark green, that lighter green, and that gray all over there. Those are like the lowest level nodes where we actually have like constant values. We know that this is 1 plus 2, and so those are like each one of the 3 nodes right there. But what we're going to do is we're going to take this tree of all of these nodes, and we're going to start to analyze that tree to look for our findings. Okay, so enter the Bandit. Like I mentioned, Bandit is an open source linter from OpenStack. It's been around for quite a while. I did not write it, but we're going to talk about some of the changes that I did make to it. It is being actively maintained, which is fantastic. I started this work about a year ago, and there's been a good number of changes that have been made since then. Earlier this week, when the project was still private, I rebased it so it has all the newest stuff. Worked out a few of the bugs, but it is being actively maintained. I've tried to talk to the committers to commit a little bit of code, and they seem to be pretty responsive, which is fantastic. I know, sure, like a lot of you, when you get an open source project, sometimes it can be a little bit of a crapshoot to see if it's actively being maintained or if you can get help or if there's going to be updates or anything along those lines. One of the things that I really liked it, though, is that it's very easily extensible. So everything that I have changed, or the core of what I have changed, is all self-contained within a module. So we just have a directory with an additional library that I added, and then a whole bunch of different checks. But the core of Bandit is very flexible in the sense of if you know you're working a lot with SQL backends or something like that, you could write a bunch of checks just specifically for SQL, and you could package them by themselves and have those all kept out separately. And then of course handles the heavy lifting for us already. Handles iterating over all the files, parsing with the AST tree and everything like that, because we don't want to reinvent the wheel. So that's just never a good idea. But one of the things that we wanted to address, so in my line of work trying to do security assessments, things like that, I want to find vulnerabilities. I would rather have fewer vulnerabilities, but I'd rather have ones that are directly and immediately actionable to me. Things like MD5 being used and SHA-1, that shows up just a little bit too often for my tastes. And if I'm on an assessment, there's no way I'm going to sit there and try to get a collision. So yes, probably shouldn't be using that. It's not really going to be useful to me. So what we're going to do is we're going to actually add in a core piece of functionality, and we're going to leverage it in a couple of different ways. So what I wanted to be able to do is be able to identify basically the sources of where variables are being used. One of the shortcomings of the existing functionality is that if you were looking for things like static keys, passwords, things along those lines, the way Bandit is actually doing that is it's running a regex on the variable name. So if you call it, password equals whatever, it's gonna be that's probably a password, that's bad. That's great. That'll catch a lot of things, but I don't want to catch a lot of things. I want to catch more things. So what I actually want to do is, instead of doing it based on the variable name, I want to do it based on how the information is actually being used. So I want to do it in reverse. Instead of starting with a variable that's a constant, I want to start out with where I believe a password might be being used. So in the Python standard library, you have the URL lib. If you are creating a cookie authentication object or something like that, you know where the password is going to be used in that. If you're using the Paramyco library, you know where the password parameter is going to be tokens, security tokens, APIs, all that good stuff. So you know where that's going to be. And so what we want to do is we actually want to start out with okay, we can see that's being right here. What are the possible sources of where this information may have come from? And then once we have that, we then analyze each one of those sources and try to determine, are any of them static? Can we determine which one of those ones might actually be? So that's the core. That's the core functionality. In addition to that, if we have that same functionality, we can actually apply it slightly differently to not only passwords and identifying sensitive pieces of information, but also to sensitive functions where we may want to do sort of a poor man's taint analysis. So instead of finding well, we know a password is going to be here, we know a shell command is going to be used by the OS system module, and we can tell that this variable is right here. So what we're going to do is we're going to use the exact same methodology of backtracking all the different sources of where that variable may have come from. But this time, instead of looking for static, because we don't want static in that case, we're going to look for anything that might be taintable by an attacker. So we're going to try to see does it come from the simple HTTP module? Does it come from being read from a socket? Something along those lines. So we can kind of do taint analysis that way. And of course, I really want to be able to run scans from my phone, because who doesn't want that? I have the push bullet app on my phone. I can just sit there during projects and I can share the link with my Bandit friend, and it'll push that right on up for me. Also, if I'm going a little bit quick, if anybody had any questions, just probably want to save them for the end. I'm actually looking for the time, but I will be around just right outside. All right, yeah, so the definition source, I kind of already just went over this. So basically, when we're looking for sensitive information, we want to look for anything that's being defined as a constant or anything that we can sort of do an evaluation on. In that first example, that was a bit contrived, where it was like var equals 1 plus 2. We can tell that that's an expression, but something like very, very simple like that, or like string concatenation or something like that, we can actually evaluate that within the AST module and say, well, like we know the entire value of this. That becomes useful when you have larger things, maybe like an embedded certificate or a database connection string, where because the string is so large, it might be concatenated over like multiple lines, something along those lines. We don't want to miss that. But once we have that like fully concatenated, we could also do like a regexes on it or something like that if we want to like weed those out from the module checks that we have. All right, so like I mentioned, Python is very, very dynamic. So when we're actually like looking for the variable sources, these are the 6 like primary sources of where like some kind of a symbol can be defined. Now there's slight variations on some of them. For example, like with the import statements, you can do import OS, and like that's one variant, but you can also do like import OS as foobar, or from OS import path as foobar, something along those lines. And so those are like slight variations in terms of how like the AST module handles it, but I'm trying to keep it simple here. But there's all of these 6 different things that I know of that will result in like a symbol actually being defined within the namespace. What this is important for is that when we're starting to look in reverse to try to identify like where a variable may have come from, these are the nodes that we're actually going to be looking for, and we're ultimately going to try to see, is it a constant or is it another symbol that might be a function that we contain, like sock.receive, something along those lines. Yep. And then once those are identified, we're going to decide if it's static or taintable depending on where it's going and like what we care about. All right, so this is a very contrived example, but this is just kind of trying to show, this is absolutely horrible code and very much contrived, but this is kind of going to show of like the different various sources of where like the functions might actually be identified. So in this case, what we would probably be interested in is we're going to be looking for sensitive information, and we're going to know that that connect function takes a keyword argument, a password. So despite the fact that it's called token, we want to see if that token variable, no matter what it's called, we want to see is there any place where it can be statically defined. So within that, we have all of the highlighted locations are all the locations that this is going to identify of like where that symbol could be defined within this namespace. So when the analysis is actually running, what it's going to do is going to take that starting point of that connect, and it's going to work its way all the way back up the tree to the module level in order to identify where those sources could be. It's going to go up to the function first, and then it's going to go up to the module, and that's just because that's how the namespaces work within Python. If a name is not defined within the function, it's going to look to see if it was like defined within the module. And then if it was defined in like the globals from like another module, kind of like all bets are off because it's not really a way you can easily identify that. But looking within this context, so we can see that first is being defined as like the function argument, then it's the return value of that get default admin password, then we have it there within that loop. And so that loop is going to be the first location where we can tell that there is a static value that this token might be. So in this case, we probably want to try different usernames with the password of some failover value. We probably want to try that password. In addition to this value will probably work. So for whatever reason, this contrived example is going to it's going to try that. So the developer thought it might work, so we're going to try that. All right, so modifying Bandit. So like I had mentioned, there's the 2 main components, the changes that are actually in Bandit and all under the SS secret sauce module. And those ones are all prefixed with like the SS check, because each one of the Bandit checks is going to have a unique numerical identifier. So I have the forked Bandit core. I have it rebased as of earlier this week. And then we have that Bandit scan manager, which is going to scan those shared links from Pushbullet, and it's going to make a nice actual like PDF report. If anybody has actually ever used Bandit before, it has a few different output options. There's like a screen option, straight text, JSON, stuff along those lines. But we don't actually ever get to have like a nice actual report that we can take a look at. Mostly, once again, wanted that because it would be easier to look at on my phone. So I have about 20 new checks. Some of the most effective ones are checks for sensitive information in third-party libraries. So I'm looking for things like SQL Alchemy, connection strings, Paramyco, usernames and passwords. One of the ones I need to add in is like the Boto library for working with like Amazon S3, because I've been told a lot of people accidentally push up like hard-coded credentials up onto onto GitHub. As it is right now, it's only it can scan like Jesse James can pull down and scan like the master branch or any branch that you would like, but it'd be pretty trivial if you wanted to do a very specific commit. So if you're like, I know they're running this commit, if you just pull it down, check out that commit, you can then use the scanner to scan it offline and do the analysis that way. All pretty straightforward. But so some of the ones that we're actually going to be looking for taint analysis are actually going to be like directory traversal. So instances where we may be able to write files outside of where we should be able to. In that case, as well as like the straight up built-in open call, things along those lines. So those are going to be a couple of ones where we're looking for taint analysis, not necessarily just sensitive information. So when this comes back, this is what I had started earlier on. Our report is going to come back and it's going to give us real simple findings. It looks like it's actually coming from me because that's how the bot works. So I'm telling myself. And then we're going to get to look at the PDFs. And so these all get queued up on the worker system. So if you're pushing up multiple links, it's just all gonna hang out right there. Okay, so for the first of the ringers, this is a popular Python project. This is actually, somebody mentioned set. Right, somebody had mentioned scanning set. So this is actually one of my favorite ones. So this is an excerpt from the report, and we can see that this is severity high. We have that SS highlighted right there because I was specifically looking for the findings that like I had added, and we can tell in this case it's complaining that that open call down there is able to be tainted. And now you can't really see because we only have like 4 lines of context right there, but when you go and you actually like manually verify that, if you look up just a little bit, just like the description says, that self.path is being tainted from the GET request. So this is an instance of directory traversal in set. I mentioned this to Dave Kennedy, so he's aware of it. I'm going to post the details onto the set project on Monday. But this was definitely not being identified before by like the base checks within Bandit, but we're able to see through the taint analysis that is definitely there. The other one, Google has over 1,000 repositories on GitHub. So on the way down, I started analyzing, just pushing up a whole bunch of them to the analysis engine that were marked as like language of Python. I think I did like the first 2 or 3 pages. But this one right here, I have not had time to like go in and like manually validate it. I'm guessing this is probably like a test configuration or something along those lines, I hope. But right down there, we can see the SQL Alchemy database URI, so we can tell this string is being utilized as the SQL Alchemy connection string. And right there within it, we have MySQL database password of root at localhost for ggRC dev test. Actually, well, there we go. I guess this is actually just a development system, but you have it. So probably something you may want to look for if you were doing an assessment where this might be deployed. Maybe you want to check out root passwords for MySQL because you have instances of where they think they might actually be being used. And with that, it looks like we have just a couple of minutes to look through a couple of the projects that may have been there. So does anybody have any questions while I pull those up? Anybody? All right. So somebody had asked about responder, right? Responder, okay. Well, let's try the live ones first. I've looked through Responder, not that great. Nobody needs to see that Shadow Brokers. I was actually running it on FuzzBunch. Unfortunately, spoiler alert, there wasn't a whole lot. A bunch of instances of where subprocesses were being executed with like shell equals true, but that was like one of the built-in checks, so you don't really know where like those variables are coming from. All right, so let's see now. Scapey, I know Scapey was one. Come on, little phone. Chug, 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 chug. Ah, here we go. Okay. Oh, wait. But this is Scrappy. Did I accidentally do Scrappy? I might have accidentally done Scrappy instead, but all right, let's take a look at this one. My apologies.
This is 19th, generated on the 19th.
Was that on the 19th? That's not today. Okay, that might have been one of the ones that I seeded with. At one point, I was going through like Google's like top projects, and we were analyzing those. I really hope the scan actually came back. I bumped my DigitalOcean's memory like way up because I was worried the analysis wouldn't actually finish. So what was the first one we had done? Not one of the things I had to end up doing to get a lot of the context is that I actually had to end up running the analysis in a loop multiple times. So it's broken out into phases, and what that's going to facilitate is eventually being able to like build a call graph. So that way you're not just limited to where variables are being defined within the scope, but you could actually look slightly like above what the call stack may be to see if it's being defined above. And in doing so, like it bumped up the scan time by like 5 minutes. So.
Was there anything interesting in SQL Map?
SQL Map, yeah, let's take a look at that one. SQL Map project. I don't think so. I think a lot of these, the good ones, I took out and put into the presentation, but there's always a chance I may have missed one or two. A few of the high findings. I don't think this was any of the ones that I had it in. But this entire PDF report was all in the Jesse James project. Oh yeah, raw SQL expressions. There's a few projects with that. Responder actually also has a lot of like the raw SQL strings because of how it's utilizing the SQLite driver. When actually like going back and trying to like manually validate those, a lot of those didn't really look like they were immediately exploitable. Like you could like send a frame in a response or anything like that and get the information in. But let's see if we can hit up like one more. Man, I'm not seeing any of them from this. That first one might have just taken too long. Any questions while we're waiting for this to load? Nope. Responder. Yeah, that's right. Responder. There we go.
Besides Bandit, what does Bandit only do Python?
Yes, Bandit only does Python. Yeah, I haven't.
Breakman for Ruby as well.
Breakman? Not sure. Python enthusiast. Sorry. Yeah, most of them are just those raw SQL expressions. There's a couple of instances where string concatenation, but like it didn't look like it was immediately usable, but was identified. All right. Well, sorry the scan didn't come back, guys. Good thing had that seated up. But if anybody else has any questions, I'll be around. I don't want to hold up the next people. But so thank you very much.